All right, so today we're going to talk about the algebra of matrices, and we're going to perform operations on matrices, and we are going to solve matrix equations. All right, and then we are going to add and subtract. So the operations are adding and subtracting, and we're going to multiply. The multiplication is going to be a little bit different, but the addition and subtraction are very intuitive. Okay, so we're going to perform operations on matrices, and we are going to solve matrix equations. Okay, so the first thing we're going to talk about are equal matrices. So matrices are equal if and only if they have the same entries in the same positions. Okay, so they have to have the same dimensions. Okay, so I'm going to start off pretty simple here. So it says to find A, B, C, and D if A, B, C, D is equal to 1, 3, 5, 2. So A is in the same position as 1, so your A value is 1. B is in the same position as 3, so B is equal to 3. C is equal to 5, and D is equal to 2. Okay, so if they're in the same position, you can just solve that way to find them. Okay, we're also gonna do addition, subtraction, and scalar multiplication. Scalar multiplication just means you're multiplying a matrix by a constant term, and you can add or subtract matrices if they have the same dimension. So they would both have to be a 1 by 2 or a 3 by 4. Otherwise, we are going to say that their sum or difference is undefined, because if they're not the same dimension, you can't add those positions together. Okay, and when we add or subtract, we are going to add or subtract what is called the corresponding entries. So we talked a little bit about positions before. If entry is in A11, first row, first column, you add that to B11, the first row, first column of the second matrix. Okay, and then to multiply a matrix by a number, all we have to do is distribute, so multiply every element of the matrix by that number. This is called the scalar product. So that sounds pretty fancy, but it is a very simple process. Okay, so in example 2, we're going to be using these matrices, so A, B, C, and D. Okay, and I took this information box from your textbook, so when you're finding the sum, you are just going to add the values in that position. So that's Aij plus Bij. Remember where I is the row, J is the column. The difference, you're going to subtract those, and then the scalar product, you're going to multiply each entry by that constant term. Okay? So we're going to carry out each indicated operation or explain why it cannot be performed. So for the first one, we have A plus B. So we want to make sure that the dimensions are the same. Let's look at our dimensions here. So A is a 3 by 2. What's B? A 3 by 2. Do you guys remember what this one is? 2 by 3, and then this one's a 2 by 3. Okay, so that's going to help us when we do those. All right, hey, let's go. Okay, so if you have A plus B, if they're both 3 by 2s, which they are, then you're just going to add the elements. Okay, so 2 plus 1 is 3. Okay, so I want you to do all the rest of those without your calculator.
He's not even yet to answer. I don't know, but Joel said his phone today. Yeah. Do it.
Okay, so like if it's after that, we're just focus.
Yep.
Okay, good. All right, so A plus B. Nice to see some of you have not done this. Okay. All right, so we have 3, we have -3. What do we get for the next entry? Row 2, column 1. -3, great. 5 plus 1, 6. Sorry, the next one is 9. And then what's -1/2 plus 2? What? 3/2. What did you guys say though? I heard root tree, and I was very confused. Okay, so yeah, so 3/2, so it's okay if you roll 1.5, but we are generally going to keep them as improper fractions. Okay, so C minus D. Because these are the same, we can subtract. So go ahead and do that. All right, and then go ahead and go to C and D. Okay, keep going. I would apologize for the fastiness, but some of you deserve it today. It's really, I just want you guys to keep going because I know that a lot of this is intuitive and you can do it, okay? So I want you to keep forging ahead. All right, so the first row, when you add it, you should have 1, -3, 6. You guys tell me the second row. Good. Now sing that in unison. Wouldn't that be great? The chorale response. When you guys were what?
Chorale isn't really good. We're all struggling. We're singing revolting to a bird from the
Oh.
Okay, no.
All right. Now, when you try to add the C plus A, C is a 2/3. A is a 3/2. So we're going to say undefined. It says explain why. All you have to say is that they're different dimensions. Okay, different dimensions. Sure. Yeah. Okay, and then 5A. All we have to do is distribute. So 5 times 2 is 10, 5 times 0, 5 times 7, 5 times -3, 5 times 5, 5 times -1/2. Right? So that's kind of easy peasy lemon squeezy, am I right? That's what you guys were thinking?
Yep.
All right, let's keep on keeping on. Now we are going to do some solving. And when we are doing the properties of addition, we are going to look at the commutative and the associative properties. Okay, so for addition and subtraction, the commutative property applies. So it doesn't, it doesn't matter if you add A and B or B plus A, the order doesn't matter, okay? When we get to multiplication, it is going to matter, which is why we talk about this. And then the associative property also applies. So if you were adding three matrices together, it doesn't matter which two you add first and which one you add last. Okay, you also have the associative property for scalar multiplication, which means it doesn't matter if you multiply B times the matrix and then multiply by C, or if you multiply C by D and then the matrix. I know sometimes the letters are confusing. The capital letter A is the matrix. The C and the D are just adding numbers there. Okay, and then the distributive property is also going to apply, and it doesn't matter which order you do those in. That's for me. Okay. I know. All right. So we're gonna solve the matrix equation. So we have 3x. This is the matrix equation. 3x minus 4a equals b. Okay. And you can just jump in if that's not too. Okay. So they give you the matrices A, where A is equal to this value, and whoopsies, forgot my little b there. So b equals, we can just put that ahead, above it. So the first thing we're going to do is we're going to solve the equation for x. So if you're solving this for x, the first thing we're going to do to both sides is, do you guys know? What would you surmise? Yep, add 4a. Okay, so because these are commutative, it does not matter if you write b plus 4a or if you write 4a plus b. B plus 4a is fine. Now, normally we would divide, okay? But the skills we've learned are addition, subtraction, and scalar multiplication. So instead of dividing, we can multiply both sides by, yep, so we're going to multiply this side by 1/3. And when we multiply this side by 1/3, we're going to write it like that. So there's a couple different ways you can do this. If you distribute, then your x value is going to be 4/3 times a plus 1/3 times b. So now we're going to plug in those matrices and we're going to evaluate. So you could do this, or you can think of it like this. X equals 1/3 times 4a plus b. So either one of those are fine. Phones are going to the office today. They're out. So which one do you guys think is going to be easier? So with this one, you're going to multiply everything by a fraction. With this one, you're going to multiply everything by a fraction. But with this, you could add those together and then just multiply at the end by a fraction. So I might go with this one. Okay, either one of those are going to get you the same thing. But if you have 1/3 times, if you do 4 times a, I'm just going to write our matrices in there. Plus your b. You still follow the order of operations. So what comes first, division or multiplication? Multiplication. Okay, so let's go ahead and multiply, write that new matrix, and then we can add them together. Alright, so when you multiply by 4, you should have got 16 15, -4, 12, and 8. How did that go? Okay, and then what did you guys do next? Good. So you have 1/3 times 3, -3, 9, and 6. Okay, and then from there, your final answer will be 1, -1, 3, and 2. So when you're multiplying by a third, it's the same thing as division, but we're writing it out like that because that is our scalar. So your final answer is x is 1, -1, 3, and 2. Okay, so that's going to be your final answer. Alright, so I think everything we've done so far has been intuitive. Like if I didn't even tell you how to do it, you guys could have probably guessed everything we just did, right? Okay, now we're going to do matrix multiplication. So when we do multiplication, there has to be a certain pattern in the dimensions in order to do multiplication. And what we do is we multiply the columns of one matrix by the rows in the other matrix. Okay, so multiplying the two matrices is more difficult to describe than the addition and subtraction. Okay, so first we're going to take this product of two matrices, and we know that it can only be defined when the number of columns in A is equal to the number of rows in B, okay, where A and B are both matrices. This means if we write those side by side, the two inner numbers must match each other. Okay, so if you look here, you have the n and the n. If those match, then the result is going to be the outside dimensions, m and k. Okay, so the result would be a matrix. Sorry, my Zoom is not working today. Okay, so the result is an m by k matrix. All right. So I'm going to show you an example just with numbers real quick. We're going to put it right here. So if you had a 2 by 3 matrix and you wanted to multiply that by a 3 by 4 matrix, if we line these up, if these two match, then we can multiply. If they don't match, we cannot multiply. Okay, and then the result would be a what? A 2 by 4. Okay, so again, with these, if these two match, your result is a m by k. So before we describe this procedure, we are going to define what is called the inner product of row A and the column of B. Because when they define this, they use the term inner product, and we haven't talked about what that means. Okay, so the inner product is when you take this A1, A2, AN, okay, and that is in a row of A, and then you are going to multiply values in a column of B and find their sum. Okay, so the inner product is honestly similar to the dot product. Do you guys remember when we found the dot product, how we multiply them together and then we find the sum? Okay, so it's very similar. You multiply the first element by the first element, the second by the second, the nth by the nth, and then you are going to add them together to get one number. Okay, so we're going to do this example together. So if you are doing the inner product of these values, Okay, this is going to give, so what we're going to do is we're going to multiply 2 times 5. Okay, so this is A11, this is B11, or sorry, they call it A1, I'm sorry. We'll do that the same way. Okay, so we multiply A1 by B1, okay, which is going to be 10. I'll just write that below. Then we're going to multiply A2 by B2. So negative 1 times 4, which will be negative 4. Okay, and then we're going to multiply 0 times negative 3. 0 times anything is 0. And then A4, B4 should be a B. Okay, and then 4 times 1/2, which is 2. So when you guys are doing this, you will probably want to write this down just to help you from making small mistakes. It just depends on what you can handle in terms of your mental math. I'm somebody that likes to write this part down, so I can only compute one thing at a time. I'm doing that, and then I'll compute for a second. So 6 plus 2 is going to be 8. Okay, so then that is going to be your entry. So that's going to be one entry there. Okay, the difference is this was like a 1 by 4 and this was a 4 by 1. So if those were your matrices, you would only have one element in it. Okay, but it's very rare that we're going to have that. Okay, so now we can reveal the definition of the product of two matrices. So if you have a matrix A and a matrix B, then their product, the M by K matrix, consists of C, which is where this is the inner product of the ith row and the jth column. Okay, so we write the product as those two are multiplied together. So again, I don't feel like that is super helpful. So we are going to do an example together. So it says that each entry in this matrix is obtained from a row of A and a column of B. So if this is the second row, we're going to multiply it by the second column and then find the sum of those. Okay, so if you did the second row in the second column, we would call this entry C22. So that's the inner product of row 2, column 2. So that's what it means. Right? I know that sometimes those information boxes can be confusing, but I want you to be able to interpret them so that it can make more sense to you. Okay, so if you have the second row and the second column, you will end up with one number. Okay, it's the sum of those products. So it says let A equal this matrix, B is this matrix. We're going to calculate the products AB and BA if possible. So earlier we talked about addition and subtraction being commutative. Okay, we're going to see if that works with multiplication. So the first thing we're going to do is AB. And when you do A times B, sorry, I'll write the multiplication as like this so you don't think it's the dimension. Okay, so A is what matrix, or what by what? 3 by 2. So it's always the row, then the column, and then B is a 2 by 2. So the inner ones match, which means you can multiply. Sometimes I put a little check, like, yep, that means we can do this. So the result is going to be a 3 by 2 matrix. Okay, so when we do this, I'm going to write this out so I can mark it up. We're going to multiply 4, 1, negative 3, 0, 2, negative 1. Okay, by negative 1, 2, 3, 1. So the first thing we're going to do is we are going to multiply the first row by the first column. So it's first row, first column. So if we're doing first row, first column, we're finding C11. That's the result. Can you guys tell me what I'm going to multiply first based on what we just did? 4 times -1 plus. So we do the first times the first, and then the second times the second. So plus 1 times 3. Okay, so -4 plus 3, -1. Okay, and then our result is a 3 by 2. So that's going to go here. It's going to go in row 1, column 1. Okay, now we're going to do the second row, or no, we're going to do the first row, the second column. So we're going to do this row, and now we're going to do this column. Okay? So 1, 2. So we're going to do 4 times 2 plus 1 times 1. Okay? If you wanted to do the second row next, you could. You just be filling it down a different way, and that's fine. So 8 plus 1 is 9. So this is the first row, the second column. So this is where you would put the 9. All right. So we've exhausted both columns now. So we're going to move to the second row. So we're going to do the second row, the first column, and then we're going to do the second row, the second column. All right, and then -3 times -1. So first times first plus 0 times 3. Okay, so you have 3 plus 0, which is going to be 3. So that goes in the second row, the first column. Okay, so then for this one, I'm going to do -3 times 2 plus 0 times 1, which is -6. And then do you guys want to try the third one? You guys want to try C31 and C32? And C3PO after that? Let's give it a go. I know it does take some thinking when you're getting used to it. And then when you're done with that, you can start the process for BA. Okay, so for the last one, we're going to do 2 times -1 plus -1 times 3. And then we do 2 times 2 plus -1 times 1. How's that going? All right, so -2 minus 3 is -5. 4 minus 1 is 3. So you should have -5 and 3. And then that's your final answer. Okay, this is the product. Okay, and then it says calculate AB, so we did that. So now we're going to do B times A. So the first thing you do is line up the dimensions. So B is a 2 by 2, A is a 3 by 2. The inner sides do not match, the inner dimensions. 2 and 3, those aren't the same. Okay, so if they're not the same, you cannot multiply. So yay, we don't have to multiply that. All we have to say is that that this is undefined. Okay, so the column in B is not equal to the rows. Row by column. Column by row. Okay, so because those aren't the same, it's going to be undefined. Okay? Alright, so that means this is not commutative. So even though matrix multiplication is not commutative, it does obey the associative and distributive properties. Okay, so associative means you can either multiply A times B and then C, or B times C and then A. It just has to be in that order. Okay, and then it also is going to follow the distributive property. Okay, but what is not the same is AB does not equal BA. And that's called commutative. Alright. The next example is going to show that even when both AB and BA are defined, they aren't necessarily equal. And this is going to prove that matrix multiplication is not commutative. Alright, so we're going to let A be a 2 by 2 matrix, B is this 2 by 2 matrix. We're going to calculate the products of both. Okay, so if we do A times B, you have a 2 by 2 times a 2 by 2, so the insides match and the outsides tell you your dimension. Are you ready to try that multiplication on your own? I like to physically write down, I will do this, and I will do this for the first part, just because that helps me. Okay, so it's 1 times 6, it's 2 times 2. And then we do the first row, the second column. So 1 times 0, 2 times 3. And when you're organizing them in your solution, row 1, column 1, row 1, column 2. Alright, so you guys find 2, 1, and 2, 2. And then you can do B times A. And then I'll look around, so if you need some help, I can help you. And then you guys can do the B times A if you're feeling good about that. So when you're doing the second one, it's negative 1 times 6, which is negative 6. 4 times 2 is 8, so we should get 2. And then negative 1 times 0 is 0. 4 times 3 is 12, so we should get 12. Okay, so then this is your final answer. Okay, for AB. Now, we just did this with the 2 by 2, so we should know that these do match and that your result is going to be a 2 by 2. But now, the 6, 0 goes first. And then the 1, 2, negative 1, 4. first row, first column, first row, second column. Why don't you just give that a whirly ball? You ever play whirly ball? I just learned about Gaga ball.
This is my glory.
Alright, so we're doing 6 times 1. What you guys gotta keep going, sorry. Did I get you off track? We talked about really ball, Gaga ball. Okay, so 6 times 1 plus 0 times negative 1. So we should get 6. Okay, and then we have 6 times 2, which is 12, plus 0. And then second row, first column. Once you get in the groove, I feel like it goes quicker. But sometimes getting into the groove just takes some brain power. And if you want to do all of those first and then write what your product is, that's fine. You have labeled what these are. So this is first row, first column, first row, second column, second row, first column, second row, second column. So this is your position. Okay. All right. The last thing we're going to do is we're going to find a product when you multiply 3 together. So they give you A, H, and C. We're going to calculate the product. And then you can choose the way that you would like to do this. So with AHC, you have 2 choices. You can multiply A times H and then the C, or you can do this. It is important to note, though, if you multiply H times C first, you cannot do HC times A, because remember, it's not commutative. So you've got to keep the A on that side, okay? So I'm going to do the AH times C. Do what you feel is right in your heart. So A is a 2 by 2, H is a 2 by 2. Okay, so that's what we're going to do first. Okay, A times H. Okay, so I will give you a minute to calculate. Okay, so 2 times 3, negative 5 times 2, 2 times 1, negative 5 times negative 1. Then I'm moving on to my second row, first column, second row, second column. 0 times anything is 0. 7 times 2 is 14. 0 times anything, 0. 7 times negative 1, negative 7. Okay, so my A times H is going to be negative 4, 7, 14, negative 7. So now I'm going to do AH times C. negative 5 halves, 2, 0, negative 3. So when you're doing that, AH times C, okay, if AH is a 2 by 2, and C is a 2 by 3, then the insides match and your result is a 2 by 3. Okay, so that's what your final answer is going to be, a 2 by 3 matrix. Okay, so I'm going to do the first row, and then how many columns do I have? 3. So I have to find C11, C12, and C13. And multiply first by the first. So it's negative 8 plus 0, negative 8. Okay, so now we're doing the second row. Negative 4 times negative 5 is 20. 20 divided by 2 is 10. 7 times 2 is 14.
Teachers, please excuse the interruption. At this time, any students taking the AP Physics exam are released from class. Please report to the vice principal.
All right, so we should have negative 8, 24, negative 21. So we've done everything we can with that first row. Now we're going to go to the second row. So the second row, first column, second row, second column, second row, third column. All right, so now I have 14 times 2, which is 28. Anything times 0 is 0. 14 times negative 5 over 2, this is what I would do. What's 14 divided by 2? There, 2. What's 14 divided by 2? 7. 7 times negative 5 is negative 35. So that's what I would do. Okay, and then negative 7 times negative 2 is negative 14. So negative 35 minus 14 is negative what? Negative 49. Okay, and then for the last one, anything times 0 is 0. Negative times a negative is going to be a positive 21. And then we're going to write our final answer in our 2 by 3. So first row, first column. First row, second column. First row, third column. And I like laying them out like this and then putting them in my matrix. So this is A times H times C. All right, and then let's look at the calendar for the homework because I adjusted it a little bit from the previous year.